Okay, with this segment, we're going to cover two areas as we're finishing up this introduction lecture. First, we'll talk about data representation. And so this will give you a little bit of an idea of how we're going to take the data, convert it to math, and then from math, we're going to be converting it into actual algorithms in whatever mechanism we're going to code that, whatever language. And then we're going to talk about the types of learning and get into more details on that front. So for some set S of samples, which various output functions is defined with these things. And so we can have a training experience. And so what is the data that we're going to be using to see how well we're doing? And so it can have this kind of a pattern. And so you have samples that are a subset of the overall set of samples that you have at hand. You can have the patterns that are specified by a fixed number of attributes. And so here we're focusing on the attributes and features with xj, and j goes up to the number of attributes. And we can have a pattern visualized in n-dimensional state space. So here we can be trying to do some type of projection for every different sample by focusing on each of the features or attributes. So we're going to have a finite set of features, vectors, x for all the n patterns, and x can be visualized as a region of a state space, where R could be how we would be using a term for that. X is the representation space. For supervised learning, and this is what we'll be getting into the next chapter, the decision attributes, the output Y is something that we would have beforehand with the training set. And for multi-class classification, this gets into pattern recognition. The problems, the domain of Y is a set V, and we'll have a set of those from 1 to m. In classification problems, each pattern S is associated with an output. The output belongs to a one-dimensional region Y of the state space. So this is getting a little bit complicated, but we're just trying to give you some of the syntax that we'll be leveraging. And so here is how a tabular form of data that would be used in machine learning. So we have the instances, and so here we have n instances, and so these are the samples. And for each one of those instances, we have n features. And so we're delineating those, and then we have the decision that we come up with some kind of result. And so this is what we're trying to do with these features. Once we get away from this training sequence, we're going to make a correct decision about what is actual there. Okay, now to finish up with the forms of learning, this is the next chapter, is what we'll talk about supervised or directed learning. And so this is a machine is designed by exploiting a priori knowledge information in the form of training examples. So you take part of your data, use it for training, and then this is how you program and give me the sensitivities that you're going to be using for your learning machine. So the supervisor has these kind of characteristics. The data set D is used for interpreting a model of the system. And so this is going to be a key thing that we're going to be doing, is we're trying to create a model of how we would generate the outputs when we're given the inputs based on this function, this f of something. So the assumption is that the machine can work on a generalized data set, and then for any input, the machine should work fine and predict it well. However, the choice of feature or attributes fed into the system will change the output. And there are two types of supervised learning. One would be classifications, so say like handwriting recognition. And the other type would be regression, is where we're focusing on the numerical prediction. So here's just some more details about the pattern recognition and numeric predictions for supervised learning. So the goal for pattern recognition is the predict that which of the M classes each new vector X belongs to. So is it an A? Is it a B? If we were trying to do handwriting recognition. And for regression, we will fit a function from the input-output data to predict output for new inputs. And so we're trying to be having a numerical type of curve generation, and fitting to that curve would be the strategy that we're leveraging there. Okay, so that's supervised. And then finishing up with this last chart is now we'll be talking about unsupervised. And this is where we get into statistical means. And so for an unsupervised learning machine, it's a machine that uses statistical methods, for example, to explore the similarities. So we have the outputs are not available, but we're given the inputs, and based on those inputs, we need to make some inferences into what type of grouping that it fits in. And so the goal is to unravel the underlying similarities in the data and make groups or clusters based on the feature vector. All right, well, thank you very much. That's going to finish our first lecture, and have a wonderful day.